Welcome everybody. Good to see so much familiar faces. My name is Menno Pot, like Chuck told already. I'm the Senior Application Technology Engineer for Dental. I've been working in dental for over 25 years and I'm also part of the application support team. I'm going to talk about the NextDent Materials. NextDent Materials, the company that makes the resins for the 5100 machine, and we have 12 applications. Exclamation mark, because 12 applications running on one machine, that's not been done by any competitor. You see printers out there having 1 or 2 applications in dental. We have 12 applications with 30 colors or resins. And all of these colors and all of these resins are biocompatible, which is very important. Biocompatibility is, of course, what's needed when we print objects that go into the oral cavity. So how do we do that? How do we achieve biocompatibility? It's part of the process. The post-processing is very important in that regard. I will talk to you about that later on. But biocompatibility, difficult word, biocompatibility is achieved also by having an in-house R&D department and an in-house test lab. The guys from R&D, a couple of them are sitting over there. I work closely together with them. I try to find applications that are printable. I go to them. We talk about the possibilities of creating a material, and they go to work. And then they come back to me, and I say, okay, maybe we have to change this and that. And we also listen to our customers very well in this regard. And finally, we have a product that is ready to print. Also important to mention is that we have our own test lab, meaning that each and every batch that we produce, before it was shipped out to the customer, it is tested. It is tested in a couple of very important functions. Strength, flexibility, stuff like that, very important. So each and every batch will be the same quality. Also, all the materials will be integrated in the software. Chuck already mentioned it. We're talking to the big software companies in dental so that the material will be there in the software. So you go to the order form, you choose the material, you choose our printer, and then everything is set. No more finding out what parameters to use, what to change, what not to do, or what to do before you can print. No, that's all been taken care of. You just design your part, send it to the machine, press the start button, and it will do the trick. Also, a very important point, printer material optimization. A lot of people think, okay, I have the NextDent material, I have a DLP system, 4 or 5 nanometers. I just pour in some resin and then it will print. It's not as easy as that. Material and printer have to be optimized. Light source, we print with a light. Each layer is illuminated for a certain amount of time. And we made that illumination time perfect for our materials. In other machines, you might find that the illumination time is too long or too little, and then you end up with a badly printed part, or maybe even worse, a good printed part, but it's, in the end, it's not biocompatible. So that's why printer material optimization is very important. Okay, we'll go to the resins now. First of all, I want to point out the new bottle. It has a wider cap, and underneath the cap there is a seal, so no more leakage when transporting our materials. And we changed the label. It's bigger, but it has all the important information you need to get started printing. Part of the IFU is on the bottle, telling you what to do before you get started with printing. And one of the first important aspects here is mixing. You want to mix the materials before you print them. Why? We use some opaque materials, and these opaque materials, these pigments in that material, will tend to sag a little bit throughout time. So if you have some stock and the bottle is sitting there for like 2 months, you need to mix it first in order to get a perfect print job. You can do that by hand, but trust me, it's very easier to get the LC-3D mixer. It's a small, affordable device which makes your life a lot easier. So you've mixed the material, now you're ready to print. let's go over all the materials and the possibilities. First of all, I want to introduce the material 2.0. We had model material for a while. That was perfectly good. You could perfect fitting prosthodontic models, but the pigment sagging in that material was quite big. So the mixing time of that material was 2.5 hours before you could use it. First use, second use, an hour, which is quite long, of course. So we got feedback from our customers. The feedback got to the R&D department. They made model 2.0, and now the sagging of the pigments is way less, so you can print faster and with less mixing time. We also listened to our customers here because we had a model ochre, and a lot of customers said, well, I like the ochre, but could you make it white? Could you make it gray? Yes, we can. So we now have 4 colors that you can print and use as a model. We have the gray one, we have the ochre, what we call peach, and the white. The white in this screen looks a little bit off-white, but at the exhibition, you can see the actual models, it's white. We also have what we call model Ortho. Now, this might be a little bit confusing, but the model Ortho is a model material that can be used to print very fast, but slightly less accurate models for vacuum casting. With the new technology, the printing is faster, like Chuck already explained. So we said, okay, what can we do with the model and the combination of prosthodontic models and ortho models? Can we not make it possible to have the same material with both options? Well, again, back to the R&D, back to the engineers, we said, yes, we can. So now we will have 2 print modes for the same material, meaning that if you want to have a gray prosthodontic model, you choose that in the software, and it will print accordingly to that particular application. So you end up with a perfectly fitting model. Press the orthodontic button, and it will speed up the process, be slightly less accurate, but accurate enough, of course, for the vacuum casting. So now you can choose a color for your orthodontic or prosthodontic models. So, when you have models, you also need gingiva mask. Gingiva mask is a slightly flexible material. You go into the software, you design your model, you slice out a piece of that model where you need the flexibility, which is often in combination with implant structures, and then you print both parts, and after that, you connect the 2 parts together, and you end up with a perfectly usable model for implant structures. We also have a cast material. Cast material, you can print whatever application you want to cast. Printing offers you freedom of form. Some things cannot be milled, they can be printed. You see an RPD here, but it's also possible, of course, to make a substructure for your crown and bridge work, or maybe even something on implants. And then you cast it. Very important that you use an investment material that we've tested, meaning that in our IFU we give several options in what material to use in order to get a good end result. Because with casting, it's not only printing, it's also the actual casting part that's very important. Next application. We have Ortho Rigid. Very early in developing, we were in contact in this particular application with 3Shape, and they had splint software, and we said, okay, let's see if we can print that. We were able to print that, and we were able to print it in a slightly blue color. I like it, but the market demanded that we could print not in blue, but in clear. So once again, we listened to our customers, we got back to the R&D team, and they started developing a colorless, clear material for splints and retainers. Milling this takes quite some time. It's quite expensive. You have to buy expensive pucks. Printing this is the way to go if you ask me. You can print several in a row, just like the denture bases you see on the machine here. And within a matter of, let's say, 45 minutes, you're able to print 6 or 7 splints in one run. And that's, of course, way faster than any printer out there, but also way faster than milling them. OK. Oh, here's a wrong picture, I see. That's a mistake. I will just skip this one. And here's the indirect bonding tray. I don't know what happened there. Indirect bonding tray, a little bit of explanation. This is a flexible material that is making it possible for the orthodontist to place each and every bracket in one go. What you will do, you go into the software, you place the brackets, the computer will help you with that, the software will help you with that, and then the orthodontist will continue in the same software and design an indirect bonding tray. That indirect bonding tray will be printed, and then in the tray you will place the brackets, and then they can be glued in one go, saving a lot of time in the chair. And by making use of this software, it's also possible for the orthodontist to do something completely different and let the design part be done by his assistant or maybe a dental lab. The only thing that the orthodontist has to do is write off on the design because we're moving teeth, so it's important that we have his signature on that, and then continue to make the indirect bonding tray. Surgical guides, also very popular. Surgical guides, of course, to have the perfect implant positioning. Surgical guides, they are out there for a long time. When I was a dental technician, I've used several of them, and I always had to buy them somewhere. And it cost me a lot of money. Now you can print them yourself. You can fit the sleeve of the implant of your choice. Post-cure the unit. It's even autoclavable, so you can use it in every operation theater, and you will have a very precise implant. You can see that in this picture we inserted the sleeve. We advise you to insert the sleeve before post-curing. The material is in its what we call green state. It's slightly flexible. Therefore, the sleeve will fit perfectly into the part after post-curing. It's locked and ready to use. So now this is the right picture to the right material. We also have a tray material. Now, printing trays in some countries doesn't make sense, but in Western Europe, the Netherlands, where we are based, it makes perfectly good sense because of the high wages that we have. So there are several labs now that use their printer to print trays all day long. But there's more to that. It's not only faster, it's more precise. You can control the thickness of your tray. You can change those settings in the software, but also the thickness of the material that you're going to use. So this is something that's not possible when you make trays by hand. So it's not only faster, in some countries cheaper, it's also more precise. Implant structures, there's a tool in there to perfectly align with the implant that you want to take your impression on top of. So now it gets interesting, I think. Denture 3D+. This is the new denture-based material. We will have that material in 5 colors. 5 colors, like pointed out before, Vertex Dental has been active in the dental market for 80 years, mainly with denture-based and orthodontic products. So we know what colors are demanded by the market. 5 colors for the American, the European, and the Asian market. And you can print your denture base, of course, after designing. After that, you can glue in the printed teeth or pre-manufactured teeth. I will talk about that in a couple of slides after this one. And you will end up with a very nice, aesthetically pleasing 3D printed denture. I'm sure that Rune is going to talk to you about that a little bit more. I found that digital dentistry, digital dentures, was not really digital. There was a lot of information that you have to put into the scanner, was what actually was handmade. And there was also a step missing. I'm a denturist. I've made many dentures, and I would like to check everything. I would like to check the height of the denture. I would like to check occlusion. I would like to check articulation. And the patient would like to see what she or he is getting. So that's why we developed the try-in material. So instead of having the wax setup that we all know, we can now design a denture, print it as one part in a tooth color. You can go back to the patient. You can check everything. If you want to change something, you go back to the software, do the change. If you think it's okay, you continue, and you can print the actual denture base. So, try-in material, I think a very good combination with the printing of dentures. We talked about teeth. We also have a tooth-colored teeth material for crowns and bridges, and also for arches for dentures. First, the MFH for crowns. You can see that we will have 7 colors. We will have a shade guide with that. This is a prototype. You can print crowns and bridges, and with some glazing and staining, you will end up with a very nice, aesthetically pleasing part. So, NextDent denture workflow. We don't sell the software and stuff, but we have the materials to create a denture workflow. Like I said, I think it's important when you make a denture that you have the opportunity to have a try-in. And if the try-in is correct, you will have to print 2 parts. You will have to print the denture base, you will have to print the teeth, and then you can glue them together. We tested this, so the MFH with the Denture 3D Plus material glued together, they stick together very well. We did some testing, of course, but it's also possible to print each and every tooth separate. It's a little bit more work, but you can then glue them into the pockets. We also tested it with printed arches, or milled arches, sorry, and we tested it with stock teeth. You can bond them with cold cure acrylic. And this is something that I want to explain because as a denturist, I know that sometimes dentures, they break, or after a couple of years, the fit is lost, so you have to reline or rebase them. All the materials that I've just shown are compatible with normal acrylics, the acrylics that we have been using for 80 years. So if a denture breaks or you need to reline it, you can go to a lab and have that done. Why wouldn't you print a new one? Well, let's say we're on holiday and something happens. They don't have a 3D printer, they don't have your file. You would want to go into the local dental technician lab and have them fix your dentures. So I already told you that post-processing is a very important part. Why? After printing, the part is in what we call the green stage. It's not hard enough. It does not have the right material characteristics yet. It's slightly flexible. It does not have the real color. It does not have the color stability. So that's where post-processing comes in. First of all, we have to wash the part to get rid of residual resin. We can use either, you use IPA or we can use alcohol. And after a 2-cycle rinse, 2 minutes, 3 minutes, then we have a clean part. It's very important that we then post-cure the part. But it's also very important that we have no IPA or alcohol on that part left anymore. So you can let them dry by air. You can use your air hose, which is available in every lab, and then post-cure. Now, post-curing is a very important part because this will get the material the right color, the right material characteristics, and the color stability, and the biocompatibility. So the LC-3DPRINT box is a very important part in the total workflow. Now, this box is rather large, but we made that large on purpose because it also is capable of fitting an articulator inside of it. And it makes use of 2 light sources. And that's important because this enables you to post-cure the parts, but also you get the deep cure. Meaning that if we have thicker parts, like a denture base, and we use different light sources, different print boxes, with the stroboscopic lights, for instance, it will not penetrate the part completely. This light box will, ensuring you that not only the surface is correctly polymerized, but the whole part. So inside of the denture, it is also 100% cured and therefore biocompatible, etc., etc.